Imagine a laboratory in the 8th century where chemistry had no established rules. Liquids bubbled in crude glass vessels, but their properties remained a mystery, often interpreted as magic rather than physical science. Early alchemists operated on a mix of local myths and ancient superstitions. Because there was no shared logic, a successful experiment was usually just an unrepeatable, isolated accident. Progress was stalled by a lack of structure. Without a way to compare materials or record data systematically, there was no way to predict how any substance would behave. But in 8th century Baghdad, an alchemist named Jabir ibn Hayyan recognized that if he wanted to understand matter, he would have to impose order on this chaos. Jabir moved away from the search for random transmutations. He began a years-long process of meticulously observing and recording how substances behaved under controlled conditions. His goal was ambitious: to prove that the physical world wasn't a collection of random mysteries, but a landscape that could be mapped through a logical framework. To find that map, Jabir subjected a vast range of materials to a single, repeatable stress test, extreme heat. By tracking how materials reacted to fire, he introduced the concept of taxonomy to the study of matter. He sorted his findings into 3 distinct behavioral categories. The first category he identified was spirits. This group contained highly volatile substances. When heated, materials like camphor and mercury didn't just change color or melt, they vaporized into steam. At the time, seeing solid crystals instantly vanish into a swirling vapor looked like literal magic. But by tracking these reactions, Jabir proved the disappearance was a predictable physical property. This shifted the study of volatile substances away from superstition and toward the first true system of scientific classification. Jabir's second pillar was metals, characterized by their durability and their ability to be molded. He noted that gold, silver, iron, and lead required extreme temperatures just to melt into malleable liquids. By recording their unique melting points and weights, Jabir provided a way to predict exactly how these metals would react to heat, moving the practice toward a replicable craft. The final pillar was stones, a diverse group including minerals, salts, and rough ores. Unlike metals, these substances didn't become malleable when heated. Instead, they would crumble, shatter, or dissolve. With these 3 categories, Jabir had a way to sort the natural world. Materials were no longer isolated mysteries. They were part of a manageable, documented system. This 3-part framework demonstrated that the properties of matter followed a logic that could be observed, recorded, and understood. This foundational concept, sorting matter by its observable behavior, is the same principle that dictates how chemistry is taught today. Before students conduct an experiment, they learn to categorize elements. This systematic approach is the global standard for scientific education. Most modern credit for organizing the elements goes to Dmitri Mendeleev, who created the periodic table in the 19th century. Mendeleev's system is incredibly precise, mapping over 100 elements into a grid based on atomic weights and chemical properties. While much more complex, this modern grid follows the same core objective Jabir pursued over a millennium ago: grouping elements by their shared behaviors. Jabir's 3 pillars were a beginning. They established the idea that the universe is not random, but follows consistent laws, a concept that remains the basis of how we map the world around us.